So our next topic is line and hyperbola. So consider the line y is equal to mx plus c and the hyperbola x square by a square minus y square by b square is equal to 1. This is the hyperbola x square by a square minus y square by b square is equal to 1. And if you want to draw a line, we can draw a line in three possible ways. In one way the line intersects the parabola at two distinct points. In the other way, the line will intersects the parabola at one point, or the line may not intersect. So in the first case, this line is, since the line intersects the hyperbola at two places, this line is secant to the hyperbola. And in the second case, since the line touches the hyperbola, it acts as a tangent. In this case, line does not intersect the hyperbola. So how will you identify the given line intersects the hyperbola or not? So for that, what we will do is, substitute the value of y in the line in the hyperbola. So it is x square by a square minus mx plus c whole square by b square is equal to 1. If you take LCM, b square x square minus a square m square x square plus c square plus 2mx c is equal to a square b square. So it will form a quadratic equation in terms of since it is a quadratic equation, there will be three possibilities: discriminant greater than 0, discriminant equal to 0, and discriminant less than 0. When discriminant is greater than 0, you will get two distinct roots, that is basically two distinct points geometrically. So it will give you, or it will say, the line is a secant. When discriminant is equal to 0, you will get two equal roots. So basically, the line is a tangent. When discriminant is less than 0, the line does not intersect the hyperbola. Among these three cases, we are more concerned about a tangent case, when the discriminant is equal to 0. When the discriminant is equal to 0, so b square minus 4ac is 0. Please note there is a change in the sign here, plus, because we have taken already minus out. So b square, so it's basically 2a square mcb square minus 4 into a into c. So now if we simplify this, let us take the common terms from here. So next, 4a power 4 m square c square minus 4, if I take minus out from it will be plus b square minus a square m square. From this again I can take a square common, this will be b square plus c square is equal to 0. So I can take 4a square out, so this will be a square m square c square plus b square minus a square m square into b square plus c square. So I can take 4a square to the rest, it will become 0. So a square m square c square plus, if you multiply with b square, it will be b power 4 plus b square c square minus multiply with this will be a square m square b square minus a square m square c square is equal to 0. I can cancel these two terms. Again, I can take b square common from this. I'll end up with b square plus c square minus a square m square is equal to 0. From this, c square is a square m square minus b square, where c is the y-intercept of the line. So if c square is equal to a square m square minus b square, then the line will act as a tangent. This is the condition for line to be a tangent. The important note which you should know is a line will never cut a hyperbola or any 2-degree curve at more than 2 points. And second point, a tangent at one branch of hyperbola will never cut or touch the other branch of hyperbola. It means, the diagram, let's take you're drawing a tangent at point P, which is shown in red color. And from the diagram you can see the same line is tangent at Q on the other branch. This case is never possible. It cannot be a tangent or it cannot intersect the other branch if it is tangent to one branch. A question based on the condition for tangency. Please pause the video and try from your end, and then you can see the solution. Show that the line touches the hyperbola if it is this. You have to prove this. So we know that the condition for tangency, c square is equal to a square m square minus b square, where c is the y-intercept and m is the slope of the line. So from this, slope is minus cos alpha by sin alpha, which is minus cot alpha, and y-intercept c is p upon sin alpha. Just substitute the condition of slope and y-intercept. You can substitute ms cot alpha or cos alpha by sin alpha, because in the left side denominator you have cos alpha. If you take LCM on the right side, you can cancel sin square alpha on both the sides. So p square is equal to a square cos square alpha minus b square sin square alpha, which you are supposed to prove. Hope it is clear to you. Our next topic is different forms of tangent. In that, first form is slope form. So equation of the tangent to the slope m to the given hyperbola y is this. The proof is same as the condition of tangency. So consider the hyperbola x square by a square minus y square by b square is equal to 1, and the line is y is equal to mx plus c. So if you see this line acts as a tangent, so we know that condition for tangency, c square is equal to a square m square minus b square. So c is equal to plus or minus root over a square m square minus b square. So the tangent equation is, so substitute the y-intercept value to the line equation to get the tangent equation. So y is equal to mx plus or minus root over a square m square minus b square. Next, second point, note there are two parallel tangents having the slope m. Yes. So if this is a tangent with slope m, similarly you can draw one more tangent having the same slope. So that is what the second point says here. What will be the coordinate of point P or the point of contact? The point of contact you will get by solving the line equation with the hyperbola, which results as, so upon solving you'll get the coordinate as this. Hope it is clear. Second form is point form. Let us take hyperbola x square by a square minus y square by b square is equal to 1, and take any point on the hyperbola to be point P whose coordinate x1, y1. As you know, you can draw only one tangent passing through particular point. So equation of tangent is t is equal to 0. So the same thing which we did in circle, parabola as well as ellipse. Whenever t involves, you have to remember the replacement logic, that is replace x square by x1 and y square by y1. So if you do that, you'll get the equation of tangent, which is x1 by a square minus y1 by b square minus 1 is equal to 0. I'm taking 1 to the left side. This is the equation of tangent passing through the point P x whose coordinates are x1, y1. So in the point form, there is one more topic, which is tangents from an external point. Let's take a point P lies outside the hyperbola. You can draw two tangents either to the same branch or to the different branches. The condition for those we will see later. As of now, what we should know is, if the point lies outside, we can draw two tangents. In this case, let us assume tangents are to the same branch. So hyperbola is x square by a square minus y square by b square is equal to 1. Now, how to get the equation of tangent from a point P x1, y1? There are certain steps which you need to follow to get the equation of a tangent. First step is, consider equation of tangent as the slope form. Y is equal to mx plus or minus root over a square m square minus b square. Now substitute point P x1 y1, because this point lies on the tangent, in the equation of tangent. So you will end up in a quadratic equation in terms of m. Make a quadratic equation in terms of m and get the value of it. Once you got m value, substitute the value of m in the above considered equation of tangent to get the required equations of tangent. The third form is parametric form. So parametric form is just the extension of the point form. So if you take the hyperbola x square by a square minus y square by b square is equal to 1, then its point form of tangent is x1 by a square minus y1 by b square Either you can write -1 on left side or 1 on the right side. So if that x1 and y1, a point on the hyperbola where you are drawing a tangent, if you replace by its parametric coordinate, which is a secant theta comma b tan theta, you will get the parametric form of a tangent. Just substitute this value, you will get x a secant theta by a square minus y b tan theta by b square is equal to 1, which upon simplifying, so x secant theta by a minus y tan theta by b is equal to 1. This is the equation of tangent in the parametric form, or we can say parametric form of a tangent for hyperbola. A question based on the forms of a tangent. Find the equation of tangent to the hyperbola x square minus 4y square is equal to 36, which is perpendicular to the line. Okay. So basically it is the slope form of tangent, because we have to find the tangent which is perpendicular to the given line. So given line is x minus y plus 4 is equal to 0, whose slope is 1. So slope of the tangent, let me take mt, that will be -1. So since we know the slope of the tangent, we can use slope form to find the equation of tangent. So slope form of tangent, y is equal to mx plus or minus root over a square m square minus b square. Here m is basically mt. So let me write it in the standard form to get the value of a square and b square. So divide it throughout by 36. So you'll get x square by 36 minus y square by 9 is equal to 1. So y is equal to minus x plus or minus root over a square is 36 minus 1 square minus 9. So y is equal to minus x plus or minus root over 27. If you want to simplify it, x plus y plus or minus root 27 can be written as 3 root 3 is equal to 0. So here you will get, as I said, for the same slope you will get two equation of tangent. One you will get by taking plus 3 root 3, other by taking minus 3 root 3. Hope it is clear to you. Our next question, before I solve, please pause the video and try from your end. Later on you can check the solution. Question says that find the locus of point of intersection of two tangents of hyperbola if their product of the slope is c square. So if you can remember, you have to use the tangent from an external point. The diagram looks this way. So this point is the intersection of two tangents. I want to find the locus of this. So whatever the point you want to find the locus, please take it as h comma k. So just follow the steps to find the equation of the tangent passing through point p h comma k. The same procedure you have to follow. At the end there will be a small change which will give you the locus. So first step is write the equation of tangent in the slope form. Y is equal to mx plus or minus root over a square m square minus b square, and then substitute the point h comma k. So in place of x and y, replace with h comma k plus or minus root over a square m square minus b square. Now you have to frame a quadratic equation in terms of m. So before squaring, take mh to the left side. Now if you square it, there won't be much trouble. So square on both the sides. K minus mh whole square is equal to plus or minus root over a square m square minus b square whole square. So here if you expand it, k square plus m square h square minus 2 hkm and here plus or minus and root will not be there if you square it. So now if you make a quadratic equation in terms of m, it would be h square minus a square minus 2hkm plus k square plus b square is equal to 0. So you framed a quadratic equation. Now this is a quadratic, obviously it will have two roots, basically two slopes here. The roots are slopes here because the quadratic equation in terms of m. They have given product of the slope is c square. So which means m1 m2 is c square. So remember the quadratic concept, product of root is c by a. So k square by b square by h square minus a square is equal to c square. So from this k square plus b square is equal to c square into h square minus a square. Finally replace k by y and h by x. So this is the required locus for the given condition. Hope it is clear to you. Our next topic is a common tangent. The question might be between two hyperbolas or one hyperbola, one ellipse, or one hyperbola, parabola, or with the circle. Here we have taken one simple example where we can learn how to find the equation of tangent between a circle and a hyperbola. Same logic can be used for other conic section also. So let us write the standard equation of, let us write in standard form. So the given hyperbola is this. So divide by 144, you get x square by 16 minus y square by 9 is equal to 1. So it is x square by 4 square minus y square by 3 square is equal to 1. And here the circle is given whose radius is 3 and the center is 0, 0. If you draw the diagram of it, it will be something like this. So vertex is 4, 0 and this point will be 3, 0. So they are asking find the common tangent. It could be 1, 2 or 3. So common tangent is something like this. The line which is a tangent to both the curves. This is one of the common tangent. How will you find this is by using the slope form of tangent for both the curves. So equation of tangent for hyperbola, slope form y is equal to mx plus or minus root over a square m square minus b square. This is for hyperbola. Same thing, equation of tangent for the circle, y is equal to mx plus or minus a times root over 1 plus m square. So let me take the hyperbola equation as 1 and 2. So both represents the same line as we are finding the equation of common tangent. So from this what I can say is from 1 and 2, since it is a common tangent, root over a square m square minus b square is equal to a times root over 1 plus m square. Here a and b represents hyperbola and here a represents the radius of the circle. So let us substitute it. So a square is 16m square minus 9. So 3 into root over 1 plus m square. Square on both sides, you will get 16m square minus 9 is equal to 9 plus 9m square. So which will be 7m square is equal to 18. So m is equal to plus or minus root over 18 by 7 or plus or minus 3 times root over 2 by 7. So substitute in either equation 1 or 2. So in equation 1, y is equal to m is here plus or minus 3 root over 2 by 7 plus or minus root over a square, which is 16 into m square is 18 by 7 minus b square is 9. So y is equal to plus or minus 3 into root over 2 by 7. So here I have 18 and here I have 9. I can take 9 out. It will be 3 times root over 16 into 2 by 7 minus 1. Y is equal to plus or minus root over 2 by 7. 3 into 32 minus 7, it will be into 5 by 7. 5 by root 7. So you will get y is equal to plus or minus root 2 plus or minus 15 by root 7. So if you see, this is the equation of tangent. Please think of how many tangents are possible. There are 4 tangents. By taking plus sign, plus minus, minus plus and minus minus, which means there are 4 common tangents you can draw between the given circle and the hyperbola. Hope it is clear to you. Our next topic is directed circle. Like ellipse in hyperbola also, it is defined as the locus of point of intersection of perpendicular tangents. That locus will form a circle. That circle is called directed circle. So, equation of directed circle of ellipse is, if you take an ellipse, its directed circle will be x square plus y square is equal to a square plus b square. As I told you, there is an analogy that if you replace b square by minus b square, you in ellipse formulas, you will get most of the hyperbola formulas. The same thing applies here. Our hyperbola equation is x square by a square minus y square by b square is equal to 1. So its directed circle equation will be replace b square with minus b square. But one thing you should be careful here is the radius of directed circle is root over a square minus b square. So directed circle is possible only a is greater than b. So in that case, radius exists. So that is what it is given in these points. Hope it is clear. Our next topic is properties related to the tangent of the hyperbola. So these are the common properties among the conic sections. So we are not going to do in detail proof of this. The first one is, which is very popular among the conics, the portion of tangent between the point of contact and the directrix subtends right angle at the vertex. So from the diagram, this is the tangent and this is the directrix. So a portion of tangent between the point of contact and the directrix subtends right angle at the focus. Our second property, tangents at the extremities of the focal chord intersect on the corresponding directrix. So what does it mean is, the line passes through the focus is nothing but the focal chord. So at the end of the focal chord, let's take P and Q. If you draw a tangent passing through the extremities of focal chord, this line is directrix. So for this focus, this is directrix, so it will intersect at the corresponding directrix. Similarly, if you draw a tangent at the extremities of focal chord passing through this focus, say S dash, then it will meet at this directrix. That is what the corresponding directrix means. Third property, the locus of fit of perpendicular drawn from focus of the hyperbola upon any tangent lies on the auxiliary circle. So it is any tangent, and from focus you are drawing a perpendicular line that is meeting the tangent at T, and from the other focus S dash, let's take it is meeting tangent at T dash. So T and T dash lies on the auxiliary circle, and product of these perpendiculars ST and S dash T dash is equal to B square, which is nothing but the square of semi-conjugate axis. The next property, the foci of the hyperbola and the points P and Q in which any tangent meets the tangent at vertex are concyclic. So this is the tangent, and these two are tangent at vertex. Hope you understand the meaning of tangent at vertex, because this is the vertex A and A dash. So it is a tangent passing through the vertex, so it is called tangent at vertex. So assume that P and Q are any 2 points where the tangent meets the tangent at vertex. So what they said is P, S, Q, S dash forms a circle. They are concyclic. Concyclic meaning those points lie on a circle having the diameter as PQ. Hope it is clear.